In this video, we will look at analyzing sky exposure factors for facades. The sky exposure factor is the same for facades as it is for the ground plane. It is a measure of the proportion of the sky dome that is visible. The difference is that the point being measured is on the surface of a facade. If that facade is vertical, it means that at most half the sky dome can be visible. So a value of 0.5 means that half the sky dome is visible, which means that there are no obstructions in front of that point on the facade. A value of 0 means that no sky dome is visible. For each point on the facade, a sky dome is defined. In the diagram, 3 points are defined on the facade. The height of each sky dome is equal to the height of the point being analyzed. For points that are higher than the surrounding buildings, the exposure factor will be 0.5. For points that are lower than the surrounding buildings, the exposure factor will be between 0 and 0.5. The method of calculation is the same as for calculating sky exposure factor on the ground. If a ray hits an obstruction, then the sky dome is not visible. If a ray hits no obstructions, then the sky dome is visible. The sky exposure factor is the proportion of rays that do not hit any obstruction. Points on the facade may represent windows, or other points where people may get a view out. Points with high sky exposure factor will feel open, and will have good daylighting. Points with low sky exposure factor will feel enclosed, and if the values are very low, the daylighting will be poor. The sky view factor focuses on the radiation exchange between a surface and the sky. Similar to the analysis on the ground plane, this exchange is dependent on the angle of incidence. The difference is that, for facades, the surface being analyzed is vertical rather than horizontal. But the logic is the same. If the ray is hitting the surface at a perpendicular angle, the radiant exchange will be the largest. If the angle becomes more oblique, the radiant exchange will gradually get less. Each ray is assigned a weight using the cosine weighting law. Perpendicular rays are assigned a weight of 1. Oblique rays are assigned a weight equal to the cosine of the angle between the ray and the surface normal. The sky view factor is then calculated, in 2 steps. First, the maximum value is obtained by calculating the sum of the weights of all rays for an unobstructed horizontal surface. Second, for the analysis point, sky view factor is calculated by taking the ratio of the sum of the weights of all the rays that do not hit any obstructions to the maximum value. For vertical facades, this will produce a value that varies in the range between 0 and 0.5. When running the analysis, different points can be selected for analysis. For the ground plane analysis, we used the corner positions of each grid polygon as points of analysis. For facades, it may make more sense to select the centroid of each grid polygon. Assuming panels represent floor heights, the centroid may be closer to the eye level of the occupants of the building. In addition, the corner points of the polygons may result in certain problems for the analysis. At the corner of the building, the corner points have 2 orientations, one for each facade. And at the top and bottom of the facade, the corner points may be obstructed by the ground plane or the roof parapet. For each analysis point, rays are generated pointing at the sky dome. Note that half the rays will be pointing back into the facade. These rays can be removed, in order to improve the performance of the raytracing. Finally, the results of the analysis can be saved as attribute data on the polygons and visualized as colors. Each panel will then have a constant color.